Hello guys, it's math time. Questions and answers is here again today to handle questions for you that gives you headache at school. Today's question is talking about the parametric equation of a curve given by x equals to ct and y equals to c on t, where t is a parameter and c is a constant. Show that an equation of the tangent to the curve at the point P with parameter t is given by x plus t squared y equals to 2ct. So guys, to do this we need to know how to form an equation of a curve of a tangent from a curve, and we know that to form equation of a tangent is given by y minus y1 equals to m into x minus x1, and this m is what we call the gradient, and the gradient is a change in y with respect to x. So we need to find a change in y with respect to x, and this can be gotten by differentiating these parameters. We know that the first parameter is in terms of x and the second parameter is in terms of y. So the parameters are x equals to ct and y equals to c on t. So we can differentiate x in terms of t. So we are going to have the x on the t, which will give us c, because t is power 1, and if we are differentiating we bring the power in front and we reduce the power by 1. So c is a constant, so it's left untouched. T power 1, we bring 1 in front, so 1 times ct. T power 1 minus 1 is 0, so t power 0 is 1, so t is vanished. So we have c there. So we also can differentiate y with respect to t, but before we differentiate it, I don't want us to use the quotient rule. So we are going to change this equation to modify it to become y equals to ct power minus 1, because from the law of indices we know that 1 divided by a number or a variable is the same as t to the power minus 1. So we'll say that y is equals to ct power minus 1. So if we have ct power minus 1, we can bring this power minus 1 in front and we'll reduce it by 1. So we'll have minus 1 ct power minus 1 minus 1, and minus 1 is minus 2. So the y on the t will be ct power minus 2. We can as well change this form back to a fraction. So instead of having ct power minus 2, we are going to have minus c divided by, the division is because we want to remove this negative sign at the power here, divided by t squared. So the y on the t will be minus c divided by t squared. So again, for us to get the y on the x now, because that's what we are looking for, the y on the x, we can see that if we invert the x on the t and change it to the t on the x times the y on the t, we are going to have the y on the x from there. So we can say the y on the x is equals to the y on the t times 1 over the x on the t. 1 over the x on the t, if we invert this function, we are going to have the t on the x. So the t can cancel the t and we'll be left with the y on the x. So the y on the x would therefore be equals to the y on the t is minus c on t squared, and the x on the t is c, but 1 over it is 1 over c. So the y on the x will be equals to minus c on t squared times 1 over c. So this c can take care of that other c there. So we are going to have the y on the x equals to minus 1 on t squared. So if we have that minus 1 on t squared, then we have already said that equation of a tangent to a curve is given by y minus y1 equals to m into x minus x1. We know everything. Y1 is the value of y that is given here, c on t, and x1 is the value of x that is given here, c t, parametric value in t, and m is what we have gotten as the y on the x, which is minus 1 on t squared. So we can substitute these values in this equation to have y minus y1, which is y1 is c on t. So y minus c on t equals to m, which is minus 1 on t squared, into x minus x1 ct. So if we evaluate that, we can remove this fraction here at the denominator, this t squared. So we are going to multiply the right hand side by t squared and the left hand side by t squared. So we multiply both sides by t squared to give us this. So this t squared can cancel itself and it goes into that other t squared there. So we are going to be left with minus 1 here. If we open up this bracket, we are going to have minus 1 times x time plus, because minus times minus is positive, so minus times minus plus ct. So here we are going to open up this bracket to give us t squared y minus this t here will cancel one of the t here, so we'll be left with t, so minus ct, and minus x plus ct. So if we bring like terms together, we are going to take minus ct to the right, and if we are taking it to the right, the sign changes from negative to positive. We are also going to bring minus x to the left so that it will look like this equation that has been given to us. If we bring it to the left, we are going to change the sign from negative to positive. So we are going to have t squared y plus x equals to ct plus ct, and ct plus ct is 2ct. So we are going to have t squared plus x equals to 2ct, and that's what they have asked us to prove. So we can therefore conclude that the parametric equation of this curve given in that form will have a tangent of x plus t squared y equals to 2ct at a point P with parameter t. So guys, don't forget to like my videos, share, and leave a comment on the comment section on videos you want us to help you make with questions you want us to help make a video on. So stay with me and remain blessed. Bye bye.